Welcome to today's lesson, boys and girls. We actually are going to be combining two lessons today, 9.3 and 9.4. In 9.3, the objective is to provide opportunities for children to model multiplication with base 10 blocks. It also goes on to talk about area and fractions of fractions. We're not going to worry about that. We're just going to be concerned with exploring arrays using the base 10 blocks. And in lesson 9.4, a multiplication algorithm, which is really just a method to solve a problem. So I'm just putting method to solve underneath it, so you would know what that word means, algorithm, a method to solve. So this is to guide children as they multiply one-digit numbers by multi-digit numbers using a partial product algorithm. So kind of what you did yesterday in 9.2. Let's start with the math message. Using the fewest number of base 10 blocks possible, show the number 36. Use base 10 shorthand to show what you did on a quarter sheet of paper, or maybe your teacher would want you to do this on your slate. Now, base 10 shorthand is just simply showing, a big square for your flat, one of these for your long, and a little square for a cube. So do that now, and you can pause the video. How did you do? This is the answer, the correct answer, 36. We have 3 longs, which represent 10 each, and 1, 2, 3, 4, 5, 6 cubes, 36. So, knowing what we know using base 10 blocks, we are going to create a 8 square high and 14 square wide array model on this array grid paper your teacher will supply. Try this now. Pause the video here. This is what your answer should have looked like, either by using the base 10 block cubes and longs or drawing it on your own. And as you can see, we have 8 longs here. And then we have our cubes here, the remaining space. And when I drew it, it would look the same way, except I didn't put that line there. So now you have 8 longs, which is going to be 80. And you have, this is 4 cubes across, 8 cubes high. If we multiply that, it's going to be 32. And it's going to be the same over here. And then if we add these two numbers together, we come up with the answer of 112. Now on page 211 of your math journal, you're going to be working on array multiplication. I'm going to turn it right here so you can see it a little better. And you're going to be figuring out how many squares are in a 4 by 28 array. Make a picture of the array. So again, you could use your base 10 blocks, or if you simply want to draw them in, you could do that as well. So to model with you, we could go across 28. And then we can go up 4. And your model would look something like this. You will do the rest of the remaining page on your own, or with a partner, depending on what your teacher wants you to do. Friends, now we're going to move into a multiplication algorithm. Again, just a method to solve. Now, boys and girls, let's look at the math message from 9.4. A farmer planted 4 rows of tomato plants with 28 plants in each row. How many tomato plants in all? Write your answer on your slate. Talk to a partner about how you solve this problem. Pause the video now. There's many ways you could have solved this problem. Let's take a look at a few right here. First, you could have multiplied 4 times 20 and 4 times 8. Add those together, you would get 80 plus 32, or 112. Or you could have multiplied 4 times 30 and then subtracted 4 times 2, which would be 120 minus 8, which also comes up to 112. Lastly, what you could have done is you could have used addition and added 20 plus 20 plus 20 plus 20. There's your 4 20s. Plus 4 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 to give you your total of 112. Now we're going to solve the same problem using what's called partial product algorithm. This is a multiplication method to solve this multiplication problem. So as we can see, we have 28 multiplied by 4. So what you can do here over on the side, you can write 4 20s, because that's what you're multiplying, 4 20s, and that's going to equal 80. Your next step is you're going to multiply 4 times the 8, 4 eighths, which equals 32. You add these together to come up with 112. So first you have 4 20s, you're multiplying, then you're doing 4 eighths, adding together to get 112. Let's try another partial product algorithm problem. This time we have 23 multiplied by 6. So what we have here actually is 6 20s. We're multiplying those together, and that will equal 120. Then you also are going to multiply 6 3s, 6 times 3 right there, which equals 18. Notice how you want to have your numbers all in a line. We are adding these two numbers together, 120 plus 18, to give us 138. You could also use grid paper, boys and girls, to check your answers. These are both pages 273 and 274 glued together. And what you could do is you could go 6 high, 1, 2, 3, 4, 5, 6, and 23 across. And I know that's 10 there. There's 20, 23. Just like that. So here we have 60, another 60, and here we have 3 6 high would be 18. So that is 120 right here, plus 18 equals 138. Same as the partial product. Now let's try using the partial product algorithm with a 3-digit number multiplied by a 1-digit number. So to set up our problem, we know we're going to have 3 300s. That's what we're multiplying, and that's going to equal 900. Next we have 3 60s. Multiply those together, you get 180. Lastly, we have 3 2s. And all boys and girls should know that 3 2s equals 6. Again, notice how I have them lined up in place value order. If you add these all together, you come up with 1,000 86 for your answer. Now complete page 214 of your math journal. It's called Using Partial Product Algorithm. Multiply. Compare your answers with a partner. If you disagree, discuss your strategies with each other. Then try the problem again. Your teacher will decide if you are working with a partner or a small group or individually. Good luck and have fun, peeps.